EE123 final project. Woo!
Hi, my name is Malik, and whatever that was Lauren Newton. We're Green Eggs and Ham Radio. Woo!
The objective of the project was to transmit as high a quality image as possible within 75 seconds using our amateur radio licenses. To do this, we evaluated 3 different methods of image compression. The first was to encode the image using Dobeshay wavelets in decomposition and approximation coefficients. Secondly, we evaluated using simple downsampling and then upsampling of the image. And finally, we looked into a specific algorithm of color indexing to encode images with very few colors.
So the first method we looked at was Dobeshay wavelet decomposition, and we selected the Dobeshay wavelet over the Haar wavelet because literature shows that it provides a better peak signal to noise ratio. Secondly, we converted an image from RGB color space into YCBCR color space simply because the human eye is less sensitive to 2 out of the 3 channels, particularly CB and CR, so we can compress more. And thirdly, we use a quantization table for different decomposition levels. We can quantize the wavelet coefficients into 8-bit, and then we can transmit them, and then we can also reduce the number of coefficients to a number we can actually transmit within 75 seconds.
Additionally, we looked at simple downsampling of the image to a number of bits that we were able to transmit and then upsample on the other end. The way we improve the performance over simple downsampling and upsampling is by increasing the baud rate of the transmission from 1,200 Hz to 2,400 Hz. One final option that we had for compression was for cartoon-like images with very few colors in them. We'd assign an index to each discrete color and then transmit an image using only those indices and then rebuild the image on the other end with the colors that each index corresponded to.
We also distinguish between black and white and colored images. For the same image size, black and white has less unique data, which allowed us to compress the image data even more.
With the image data compressed, we then use gzip encoding to further compress the data in the bit stream and then send it away in the form of packets.
Unfortunately, wavelet decomposition was badly hampered by quantization errors, and a faster modem was needed to barely exceed the minimum peak signal-to-noise ratio. Simple resampling paired with the faster modem, however, gave superior results, and the cartoon returned very good results, but for a very narrow range of viable pictures.
In conclusion, we were able to exceed the minimum PSNR requirements that were set before us.